So, when you hear the word chemistry, what pops into your head? You probably picture bubbling beakers and scientists in white lab coats, right? But what if I told you the real science is happening all around you, right now, in the most unexpected places? Let's dive into the incredible and often invisible world of chemistry.
Okay, so let's start with a bit of a brain teaser. What could a non-stick frying pan and a pineapple possibly have in common? I know, it sounds like a weird joke, but the answer actually tells us something really fundamental about our world.
Believe it or not, the answer is chemistry. That amazing image you're seeing, those are crystals of tartaric acid. It's the chemical that gives pineapples and a lot of sour candies that signature tartness. And the non-stick coating on your pan? Well, that's a special polymer, a product of chemistry too. From the food you eat to the pans you cook with, it is the science behind just about everything.
All right, let's really dig into this idea. Chemistry isn't some abstract subject you just learn about in a classroom. It's the bedrock science that literally shapes our daily lives and our entire world.
I mean, just take a second and think about your day so far. The plastic your phone is made of, the synthetic fibers in your shirt, the aspirin or vitamins in your cabinet, it's all chemistry. Even the cooking oil you use or the motor oil in your car. And you know that flavor enhancer that makes your favorite snacks so irresistible? Yep, that's chemistry, designed to interact perfectly with your taste buds.
Okay, so we've got the where. It's everywhere. But what exactly is chemistry anyway? Let's strip it down and look at the official definition.
Yeah, that sounds a little textbooky, right? But here's what it really means. Chemists are basically asking three big questions. 1, what is stuff made of? That's composition. 2, how are all those little bits arranged? That's structure. And 3, what does it do and how does it change? Those are its properties and processes. It's the ultimate how stuff works science.
And you know, this brings up something huge we need to talk about. The word chemical gets a really bad rap. We hear it and immediately think of something artificial, unnatural, maybe even dangerous. But the truth is, everything is made of chemicals. Water is a chemical, H2O. The sugar you put in your coffee, that's sucrose, a chemical. The air you're breathing is a mix of chemicals. Everything, living or not, has a chemical basis.
Now, chemistry is this enormous, sprawling field, right? So to even begin to wrap our heads around it, scientists break it down into 6 main branches. And you'll see they all kind of overlap and work together. First up, we've got organic chemistry. This is all about carbon, which is the backbone of life itself. Then there's inorganic chemistry, which covers basically everything else, all the metals, minerals, and non-carbon stuff. Physical chemistry dives into the physics of it all, like the energy changes that happen during a reaction. Analytical chemistry is kind of like the CSI of the science world. It's all about identifying what's in a substance. Biochemistry is where chemistry and biology meet, studying the chemical reactions happening inside living things. And finally, there's theoretical chemistry, which is super cool. It uses powerful computers and math to predict what new molecules might do before they're even created in a lab.
So with all these different branches, how do we actually, discover new things? How do we go from an idea to a new material or a new medicine? Well, a lot of the time, it all starts with just being curious.
A whole lot of science kicks off with something called basic research. And the goal here isn't to invent a specific product or fix a particular problem. Nope, it's just learning for the sake of learning. It's driven purely by a desire to know more about the universe. And sometimes, chasing that curiosity leads to some absolutely incredible and totally accidental discoveries.
And there is no better story to illustrate this than the invention of Teflon. It's fantastic. A chemist named Roy Plunkett was studying refrigerant gases, and he came across this one gas cylinder. The pressure gauge said it was empty, but the thing was still really heavy. He wasn't trying to invent anything, he was just puzzled. He wanted to know what was going on. So what does he do? He saws the thing open, and inside he finds this weird, waxy white powder that was incredibly slippery. That accident, born out of pure curiosity, was the discovery of Teflon.
So, that whole Teflon story, it's the perfect roadmap for how innovation actually works. It all starts with basic research. That's Plunkett just being curious. That chance discovery then leads to applied research, where scientists try to solve a specific problem, like, okay, this stuff is super slippery, but how do we get it to stick to a pan? And finally, that leads to technological development, which is all about creating the products that improve our lives, like the non-stick cookware we all use.
And this path, this journey from just a simple question in a lab to a product that changes your life, well, it happens constantly. It's pretty much the engine that drives the modern world. I mean, think about how you're even watching this right now. The internet, right? It's probably coming to you through fiber optics. Well, that amazing technology was only possible because decades ago, scientists were doing basic research on how light travels through glass crystals. At the time, it probably seemed purely academic, with no real-world use. But now, that fundamental knowledge is literally the backbone of our entire digital world.
And that, right there, is the crucial point. That's what I really want you to take away from all this. It all starts with a question. A simple spark of curiosity can set off this incredible chain reaction, from basic research to applied science to technology that can completely reshape our world. And it all begins with someone just wanting to know why. So this all leaves us with a pretty exciting question, doesn't it? Right now, chemists are tackling some of the world's biggest challenges, from creating new sustainable materials to designing life-saving medicines. So the real question is, what everyday problem is it going to solve next? Thanks for joining me for this explainer.